Hello, and welcome to part 4 in our study of how science proves intelligent design. In our first few lessons, we've been looking at the human body. We want to continue with that here. I've got 4 areas that I want to deal with in this video, so I'm going to move rather quickly to touch on all of them because they're very, very important, and there's a bit of detail with each one of them. We want to move with number 12, if you're keeping track of notes. We're now going to look at the human eye. This is absolutely mind-boggling. It's absolutely amazing, fantastic, of how the human eye works. Again, I remind you, as I do in every video, it's not that we understand every single minutia about it, but look at the complexity, look at the functioning, look how everything works together, all with the idea of asking yourself, which is more reasonable, random chance or intelligent design? The human eye. Here's basically the process. Light from the sun or any artificial light source travels in a straight line, all right, and then it bounces off of an object and into our eyes. That's how we see. The light goes, it hits something, and then it goes into our eyes. Depending on the amount of light that there is, the iris changes the size of the pupil to let in more or less light. It's something we know how our eyes dilate. The pupils, the little circles there in the middle of our eyes, when there's not enough light, they get bigger, and this allows more light to come in. When there's too much light, they constrict and get smaller to allow less light. Now we know that happens, and we know why it happens, because the eye should not be damaged by too much light coming into it. If it was too much light and it's not restricted, we can't really see right, and over a period of time it would damage it. If there's not sufficient light, then we can't see properly, so the pupil opens to allow more light to come in so that we can function. Again, here's where we keep in mind, how does this happen? How does this happen? Is there not thought and design behind this? So the pupil dilates to allow the iris to get the correct amount of light. Then what happens? The light passes through and hits the lens. The lens focuses the light onto the back surface of the eye, which is the retina. And the retina is there, and the retina has to be exactly right. It's like a very, very thin, I don't want to say sheet of paper, but that kind of an idea. If it starts to get wrinkled or moved or this or that, then we don't see properly. I had that with my vision. It's called a macular pucker. And what was happening is there's a solution in your eye, which we're not even dealing with, but that started to harden, and here's my retina, which is this very, very thin layer that the light bounces off of, and as it grabs a hold of that and it starts to dry, it pulls it. So you get like a pucker. It's like taking a little thing and just pulling a little bevel into it, making it go like this instead of being straight, and that affected my eyes. If you go to the eye doctor and they give you that thing with all the little squares on it, all the vertical lines and the horizontal lines, well, they're supposed to be straight. That's why they have you look at that. If they're not and they start to get wavy, which is what was happening with this eye, I would look at the horizontal lines and they'd go like this because I had that pucker in my eye. But this shows you the precision of what needs to be in our eyes in order for them to function properly. It's not just this hole in our head that light goes into and we see. There's a multitude of processes taking place. So again, now let me get back to this. The lens focuses the light onto the back surface, which is the retina. Now, depending how far or close, focusing needs to take place. I mean, if you have 20/20 vision, you don't need glasses or anything. You look out at something far away and it's clear, you can see it. Then you put your head down and you read a piece of paper and it's this close instead of being a mile away, and yet you can still see it clearly. Well, for that to happen, because there's multiple distances, the eyes have to focus. It's like anything else that we know. You either have to zoom in or zoom out. When you have cameras, if something's closer, you got to turn it and focus it, or you have to change it. Binoculars, if something's far away, you have to refocus it to get the long distance, and then focus it again to get the shorter. It's the same with our eyes. So our eyes need to focus when something is close or something is far away. Here's how it does it. how the lens focuses light. A fatter lens bends light more than a flatter lens. A fatter lens bends light more than a flatter lens. The human eye changes the shape of the lens as we look at far or near objects to keep them in focus. So the human eye, depending whether you're looking far away or close, is changing the shape of our lens so that it will focus. This is called accommodation. That's the technical name for it. When we look at an object that is far away, the light does not need to bend for the retina in order for us to see it clearly. So there are suspensory ligaments pull on the lens to make it flat. When the object that we look at is near, the light has to bend more for the retina to see it clearly, so the suspensory ligaments pull less, so that allowing the lens to spring back into its fatter shape and see things clearly. So when we're looking at far away, there's a ligament in there that's going, and when we're looking at something at a different, it might go back again to let it flatten out, changing the shape. You know yourself, if you start to need glasses, all that's happening is that the muscles and the ligaments in there are losing their strength and your eye is changing shape. That's why sometimes if you squint, it changes the shape a little bit and things get clearer. Sometimes you can kind of like put your hand under there and, you know, move things around and things will get sharper again. It's not that the eyes are getting old and don't see anymore. It's the shape of the eye is changing. And glasses accommodate for that. I guess with the, I don't know all the technicalities behind it, but I think with the laser surgery, it starts to deal with the shape of the eye and can bring it back to where it's supposed to be, because the ligaments are relaxing and getting older and not being as strong as they should. But you see the process that's going on in order for us just to look out and to see things in focus. Let's continue on. After we receive the focused light, the retina transforms this information into an electrical impulse. It's not just you're looking at something and it goes right to the brain. The brain's not going to comprehend that. The brain's not going to get it. The body isn't made that way. It changes it into an electrical impulse which travels to the brain through the optic nerve. So you have the optic nerves in back of the eye. After it's already gone to the retina and it's been focused properly, then the optic nerve is connected to your brain, which and it transfers it into an electrical impulse. And that's what goes to the brain. And the image is received in the brain. And when it's received in the brain, it's actually upside down. When the retina sees it, it sees things upside down. Remember the old-time cameras? Just take a picture and everything was, he would see it as he's looking at it upside down. That's the way our eyes see it. Then the brain takes it and flips it over right side up so that we're not confused. Put this all together, this is phenomenally unbelievable. Let me give you a recap. Here's how we see. The pupil receives light. The iris changes the size of the pupil to adjust the amount of light. The lens focuses the light. This is accommodation. The suspensory ligaments bend the shape of the lens so that we can focus on whether something is near or something is far away. The retina transforms the light into electrical impulses. The optic nerve sends the electrical impulses to the brain. The brain reads the electrical impulses, reverses the picture so that we can see it. All of this happens in the human eye. It happens in animals. It happens in fish. It happens in birds. It happens millions of times. And I'm just skimming the surface here of what actually takes place. It's like a basic outline. Again, the question is, random chance? No designer? No intelligent design? It just seemed to happen all on its own? Think about it for a minute. Do you believe the camera that I'm speaking into, you think that just happened on its own? Do you think that just came together on its own? The lenses that are in there, the focus? Originally when cameras come out, you had to turn it and focus it. Now they developed so it automatically focuses. Why didn't it do that in the beginning? Our eyes automatically focus. Or did someone have to go in there and think this through and design it and then make it so that that camera could automatically focus? How did that lens get in there? How do all of these things happen to take a picture? so that we can look at it. Telescopes, microscopes, just happened? Just happened over time? Or are they evidence of intelligent design? Absolutely they are. We know that they are because they would not exist unless a human being made them. If those things can't exist, how can something that is monumentally more complicated like an eye just come about on its own through random chance without a designer? Makes sense? Sure does to me. Quickly, let's touch on the ears. The ears, sound waves go down through the auditory canal, and they're carried by the bones of the middle ear to the cochlea. The cochlea it's a set of bones. It's kind of like rolled up. It looks like a tiny seashell. Has a specific shape to it so that we are able to hear. Now, the outer ear naturally picks up sounds through the air, which takes it inside and transfers it to the cochlea, which is in a liquid. So you have sound going from air to liquid, which is very difficult to make that work. Very difficult to make that work. But there are 3 tiny bones that inside the ear that are just right to accomplish that. You have the eardrum, you have these tiny bones that are working in there that all enable us to hear sounds, tones, music. We can recognize voices. We not only hear a voice, but we can recognize that voice, and that gets involved into things in the brain. But we don't just hear like electrical currents. I'm talking to you now and you don't hear it. This is Fred talking to you on the camera. We're giving you where it's just a monotone sound that sounds electrical. No ups and downs, this or that. Nothing that uniquely identifies the voice as me. No, we hear that we can tell. A mother can listen and hear a baby's cry and know whether it's crocodile tears or my kid's in trouble. I mean, things get that finely tuned. We can recognize someone's voice. We hear them talk in another room. We don't have to look at them. We know who they are just by the tone of their voice. Phenomenal things that go on with our hearing. How did that happen? How does all of this get communicated to the brain so that we understand it, so that it all makes sense? Random chance? Someone designed this. Intelligent design. Let's move on. I'm hitting these quickly. Our nervous system. This I'm going to hit real quick, but this is phenomenal. Our nervous system controls 2 types of actions. We talked about this with the muscles. Voluntary actions, like I want to move, I want to walk, I'm making a decision to do something. And the involuntary actions, such as our heart beating, breathing, eyes blinking. We don't have to think about those things. They happen automatically. Now listen to this. The human body has between 95 and 100 billion with a B, neurons or nerve cells. And they're continuously interacting with each other. We're talking about 100 billion here. 100 billion things. These neurons or nerve cells carry messages throughout the entire body. And they do it through an electrical chemical process. Chemicals in our body that are charged, specifically charged in our body. They're sodium, potassium, and chloride ions. I'm giving you all the scientific stuff here. You see how I'm saying, entitling this, how science proves intelligent design? All of this stuff is coming from scientific studies. They've gone inside the body and look, and they know all of these things, and they give us these facts. I'm honestly believing that in the last days before the Lord comes back, He's putting all this information in front of us. I mean, 100 years ago, 150 years ago, we didn't know all of this stuff. We know our eyes worked, our ears worked. We knew that, if you wanted to call them, we had nerves in it, but we didn't know anything about it. We didn't know how detailed it was. We didn't know how intricate. We didn't know how they coordinated all together. We just knew it happened. I touched something hot and, I pull my hand back. Well, why does that happen? There's a detailed explanation, and it's a complicated process. It's fantastic what it is. Today, we're knowing these things. We're seeing these things. I think this is God in the last days saying, hey, folks, I'm making this as plain as I possibly can. I'm getting ready to come back. You better, I'm giving you all the info I can give you. I'm giving you every reason in the world to be able to believe that I exist. That's my opinion. When I give my opinion, I tell you it's my opinion. That's what I believe, because this stuff is phenomenal. Absolutely phenomenal. And I think it counteracts a lot of the teaching and then what we get pushed on us today of this evolution. You know, the kids in school today, I mean, they just get it crammed down their throat. And so they're getting like one side of the story here. And I think with all of this coming out, it maybe helps give them a fighting chance to say, you know what? Is this really reasonable? Think about it. There's got to be something out there, whether you're going to call it God or I don't know, but think about it. You think all of this just happened on its own? And if we do think, if we're not just naive and gullible and just take in what someone's telling us, it's going to make it very easy and very logical for us to believe in intelligent design, that there is a creator. So again, we've got this, I kind of interjected there, let me move on. You got the nerves working through the charged ions. And what this does, through these different chemicals, sodium, potassium, and chloride, this establishes an electrical current in the body. So the brain receives input from the sensory organs. It sends an output to the muscles for action, both voluntary and involuntary. That's really a broad capsule picture of how our nerves work. We reach out and we touch something, and there's a chemical reaction in our body, an electrical impulse that goes and tells our brain, I'm feeling something, I feel this desk. You reach out and you touch something hot. Whoop, that's not good. There's a whole process that takes place, we're going to talk about that, of what makes you instantly pull back. Or you reach out and you touch a pan and it's not too hot, and your hand, you can just stay there, and you pick it up and you move it to wherever you're going to move it. Things we don't even think about, and yet there's all kinds of impulses and processes taking place. All kinds of electrical currents going out, signals being sent to the brain. This is okay, that's not okay. This is good, this is bad. We can feel pain if we bang our cells or this, that, we go whoop, and we stop. Or we can feel the soft touch of a baby, and it's something that's enjoyable, it's not going to hurt us, this and that, and we enjoy it, we take it for the moment, we take it. So sensitive, either sides. This is a study to just do on your own. I'm not even beginning to do the nervous system justice, but just to get a capsule picture out there of what in the world is going on. 100 billion nerve cells interacting through electrical currents in our body. Random chance? Or intelligent design? Let's move on to the last one I want to do, and this is a bigger one here. All of these signals, all of these impulses, all the things we've been talking about, what the muscles are doing and how they're reacting, and how does all these impulses go where? They go to the brain. And how do all of these other things function? How does the heart function? How does the heart keep beating? How does the circulatory system keep going? How do the eyes read what they're doing and this and that? How does everything, the digestive system, everything that we looked at, how does it all know what to do? How do the muscles know how to respond? How does the body know how to react? Because after the impulses go to the brain sends the instructions out to the rest of the body of what to do. So let's take the time that we have left here to look at this, the human brain. The brain is perhaps, I would think without question, the most complex organ in the body. It controls everything. It's the control center. The brain is actually, I think the best way to look at it is as a complex computer. At this day and age, I told you how, we have things more today to help us understand things better. We have computers. We understand basically how a computer works. And we can think of our mind as a very complex computer. And the brain is the most complex computer, if you want to think of it that way. It's more powerful and complex than any computer that man has ever made. The brain computes and sends billions of bits of information throughout the body. Information that controls every single action, right down to the blink of an eye. Everything I'm doing, my hands moving, my speech, my hearing, being able to form language, everything. I'm breathing while I'm doing it, my heart is breathing, you're listening, you're watching, you may be doing something else while you live. Maybe you're driving a car, you're setting your brain is controlling everything. There are multiple things going on every second, and billions of messages are being sent. The brain also controls the body's chemical system. The body is like a chemical plant, all right? Far more intricate than anything man has ever built. This chemical plant in our body changes the food that we eat into the nutrients that we need. We talked about that a little bit before. It causes growth of flesh, of blood, of bones, of teeth, of everything that we have. This all happens through a chemical process in our body, which is awesome in itself, and the brain controls all of that and tells it how to work, tells it how to do it. And it takes the food and changes it and produces power and energy in order for us to live, in order for us to move around. This is why we need rest each day. And the body rebuilds itself. We get tired and it sort of, winds down, and we just get ourselves, and we go to sleep. And then while we're sleeping, the body is regenerating, rebuilding. The chemicals are working inside. So there's the complicated processes in the body, but the brain is directing all of this to happen, everything that we do. Let me quickly break down how the brain does this. Again, here's an area, I'm going to throw some big medical words at you. Don't try to memorize it. Just take in the whole overall picture, and hopefully you would sit back and go, wow. I mean, just wow. Again, looking at all of this, getting a basic thing of how it all functions, random chance, intelligent design. Here's a breakdown of the brain. You have the medulla oblongata. Medulla oblongata. This is really the most important part of the brain. Its functions are involuntary. I'm going to read this for you. We would not be able to live without the medulla oblongata. It regulates blood pressure, breathing, heart rate, and swallowing. And notice here, when I'm going to go over all of these parts, the reason for going over it is to show you how each part of the brain causes us to function. In other words, everything just doesn't go into, here's the brain, boom, it's all in there and it just happens. No, it's divided into sections, and each section has its own purpose, has its own design to it to perform specific functions. Right there shows you design. So there's your medulla oblongata. Blood pressure, breathing, heart rate, swallowing. Then you have the cerebellum. This is responsible for balance and coordination of muscles. It is extremely important for being able to perform everyday voluntary tasks such as walking, the ability to balance and stand upright, the ability to write. That's all goes through the cerebellum. People who have suffered damage to this area of their brain have a problem with balance and have a problem with walking. Third, the hypothalamus. This is responsible for behaviors such as hunger, thirst, and maintaining body temperature. Body temperature, the hypothalamus. Then you have the amygdala. This is responsible for memory and the response of emotions, especially fear. I don't understand how all of this works, but we don't need to. We just know that this is what these different things are doing. The amygdala, it controls how we react to potentially threatening or dangerous situations. You get scared, you get afraid. What do I do? Do I freeze? Do I run? There's a section of the brain that's taking care of that. The hippocampus, another section of the brain, is responsible for long-term memory. It assists with the storage of long-term memories, how to remember things. We would not even remember how to be able to get home at the end of the day if not for the hippocampus. This is the area of the brain that gets affected by Alzheimer's. You see, once again, there's a specific area, and when that area is not functioning properly, we don't function properly. The thalamus. This is responsible for relaying information from the sensory receptors. So I reach out, I touch something, I feel it, that signal has to go to my brain so that I know what in the world that I'm doing. But it not only goes to my brain, it goes to the proper area of my brain so that that part, it doesn't go over to this area where this area says, I don't deal with that. What are you doing over here? I have no idea what to do with that. It's got to go over here where you know what to do. It's like walking into an office with a certain problem, and the guy goes, I don't deal with that. That's not. You got to go down the hall to this and that, because I can't help you. There's nothing I can do because I don't deal with that stuff. You got to go see John down the hall here, and he knows how to do all of that stuff. Very simple explanation, but that's what in the world is going on. That's what's happening. So again, with the thalamus, we're looking at here, the thalamus is similar to a doctor that diagnoses or identifies a patient's disease. It diagnoses sensory information that either comes through hearing, through our eyes, through our touch, and our taste. It sends it to the right place so it knows what to do with it. It directs that information to different parts of your brain so it gets to the right person or the right part of the brain, so that part of the brain can deal with how to react. You're cooking something, you stir it around, you go, let's see if that's right. Well, right there, you're tasting it, that sends a signal, and the signal has to go to the right part of the brain to say that needs salt, it needs a little more pepper, it's good, it's bitter, it's this. You see, something we do without even thinking. Look how complicated it is. Look how sophisticated it is. Look how intricate it is. Let me move on. 7 is the pons. Not the fons, the pons, P-O-N-S. This connects the upper and lower parts of the brain, and it serves as a message station between several areas of the brain. Without the pons, the brain would not be able to function because messages would not be able to be transmitted. So all these signals are being sent. It's the pons that makes them go and gets them where they need to go. Gets them in the right place. Then we look at the brain. This is something we're probably a little familiar with. You have the right hemisphere and the left hemisphere. It's divided in half. The right hemisphere we know controls the left side of the body. Left hemisphere controls the right side. But again, there's specific functions. The right side is the more artistic or creative side of the brain. This deals with things like art and music, having insight, creativity, imagination, intuition, all these things that again are so common to us. There's a specific part of the brain that handles it and makes it work. When you're creative, when you think like, maybe if I do this, if I design this way, if I make this, if I move this over here, if I put that there or that, this is all coming from a certain part of the brain, and it is very intricate. The left side of the brain is more the academical or logical side, academic or logic side of the brain. You get analytical thought, science and math, logic come from here. Comprehension of language comes from this side of the brain. The ability to read and to write, to reason things out, to think them through, comes from this side of the brain. Phenomenal. Let's continue on. The corpus callosum. The corpus callosum. Boy, I learned a lot of stuff doing this, let me tell you. The corpus callosum connects the right side and the left side of the hemisphere. You got the two sides. But if they don't talk to each other, you're only going to be able to figure out math problems, but you might not have any imagination. They got to talk to each other. That's what the corpus callosum does. It allows communication between the two hemispheres. Then you have the cerebral cortex. This is responsible for thinking and processing information from our 5 senses: sight, sound, hearing, touch, taste. It's also responsible for the higher thought processes, including speech and decision making. The cerebral cortex is divided into 4 areas, that in itself. Let me quickly give them to you. You have the frontal lobe, which carries out the higher mental processes such as thinking and decision making. What should I eat? What should I drink? I'm studying. All of that goes into the frontal lobe. It gives you the ability to speak fluently and in a meaningful manner. Then you have the, see if I can say this right, parietal lobe. This processes the sensory information that deals with taste, temperature, and touch. The temporal lobe. The temporal lobe primarily deals with hearing and selective listening. It is key in being able to comprehend and understand speech. It also makes sense of all of the different sounds and pitches. We talk about music and understanding music and the different notes and the harmonies and this and that. This all comes from a specific part of the brain, the temporal lobe. Then you have number 4, the occipital lobe. This is responsible for processing visual information from the eyes. The temporal lobe that we talked about, that processes auditory or hearing, what we hear. The occipital lobe processes what we see, specific parts of the brain. The nerves know where to send it. The pons tells it, this is a sound, you go over here. No, this is a visual, you go over here. This is a taste sensory thing, you go over here. This is a feeling thing, you go over here. This is a smell, there's a certain aroma coming into your house. We need to process that. Well, that smell goes over there. Doesn't go over here, it doesn't go over there, it goes over there. Otherwise, you're not going to understand it. If I send the smell over to the hearing thing, it's not going to make any sense. You're going to go, what? What? You see how intricate this is? This is fantastic. And I'm giving you the light, fluffy, candy cotton version of all of this. It's unbelievable what is taking place here. Let me keep going. And again, with all of this, it's all happening in a split second. I'm talking to you and you're immediately understanding me. My brain is saying, put these words together. I'm reading a lot of the things that are here because these are all like definitions. Well, I'm instantly looking at it and it's going bum, 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 and I'm immediately able to, it's going to the right area in my brain that sends back, this is the word that you're reading, this is what you're looking at, this is how to form your mouth and put your lips together and move your tongue and this and that, and here's how you pull up the right word to be able to say it. You hear all of this that I'm doing, and it's coming out and you're hearing it and it's coming into you and you're understanding it, and it's all going bah, 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 in seconds of time. Just accident. Isn't it amazing? Isn't it amazing how things just absolutely happen with no purpose, no intent? Just give it a billion years and you got it. 12, you have the reflex arcs. I was going to break this down, but this comes to nothing more that we talked about before. If you touch a hot object, you reach out on the stove and that pan the handle's gotten itself real hot, and you reach out and you grab it. Now, if things aren't instant, you're in big trouble. If you grab that and you go, ooh, I think this pan is too hot. I think that this is going to burn my skin. I think this is going to cause severe damage. This is no good. I'm feeling pain. I'd better release the fingers from the handle of the pan and pull it back. Okay, here I go. Whoop, whoop. Ow. If that's what went on, we'd probably be burned right down to the bone. If you think about it consciously, you touch something that's hot, you don't have to think about it. You reach down and grab it and go, boom! Just like that. I mean, split second. Because how does that happen? Well, I just learned it. When it's hot, you put your... No, you did. Well, you did learn it, but instantly, there's no conscious effort has to take place. That reflex arc goes, get out of there, boom! And you're back, just like that, instantly. You touch something and stick your finger and it hurts, you go, whoa! Like that, instantly. And usually after you've already pulled back, you go, what was that? What in the world happened there? Now you start to process it. Well, the reflex arc, to protect us, is built in there that, bang, it automatically takes place. And it happens in an instant of time. The brain is a phenomenal. And again, I keep saying it in an apologetic manner. I'm not even beginning to do it justice. But I think there's enough there to look at that we can back up and go, are you kidding me? Are you kidding me? And I strongly encourage you, study it further. Dig in. Have at it. But to just look at this and go, are you kidding me? This is phenomenal. Well, science is looking to study it further. Let me give you a couple of articles here. The United States and Europe right now are both planning $1 billion investment to understand how the brain works. But the technological challenges are vast. Listen, I'm quoting you now. The director of the U.S. National Institute of Health is planning an effort for a 10-year study on how the brain works. President Barack Obama on April 2nd, I'm reading you the note here, announced a $100 million initial investment to launch, quote, the Brain Initiative, which is a research effort expected to eventually cost perhaps 10 times that amount. The European Commission has equal ambitions, and it announced that it would launch the Human Brain Project with a 2013 budget of 54 million euros. That's equivalent to $69 million. And they will contribute to its project billions of euro funding over the next 10 years. Both efforts are bold bids for the neuroscientist's ultimate challenge: to work out exactly how the billions of neurons and trillions of connections or synapses in the human brain organize themselves into the working neural circuits that allow us to fall in love, to go to war, to solve mathematical theorems, or to write poetry. So they're putting millions and millions and billions of dollars in to try to figure out how this works. Great, have at it. But if you got to do all of that to figure out how this thing works, and you're starting off with the premise of just happened, you got to be kidding me. Is that even logical? They finish up with saying they're going to reaching this goal, for them to figure out how it works, will require innovative new technologies, ranging from nanotechnologies, genetics, optics that can capture the electrical activity coursing through neurons, and then produce those neurons to find out what they do. Then they want to map the underlying anatomical circuits in fine detail and process the exabytes of information, all this to find out what it produces. Listen to this. Neuroscientist Conrad Cording of Northwestern University in Chicago says, think about it. Think about it. The human brain produces in 30 seconds as much data as the Hubble telescope has produced in its lifetime. Billions and billions of dollars, all of these intricate things to go in and to research something that just happened by chance. Does that even begin to make sense? Does it even random chance? No organization, no design. That's like me saying, here's an automobile out here. The automobile functions. I don't know how it functions. We're going to put in billions of dollars to figure out how this thing works. But ultimately, there's no design to it. There's no organization. It happened. It happened by random chance. The world's best scientists have to sit down and do 10-year studies to figure out all these complex things of something that just happened by random chance. Something that in 30 seconds is producing more data and information than the Hubble telescope has in its whole existence. I say, think about it. Think about it, folks. Absolutely think about all of this research and study just came about by random chance. What did we look at here? Let me recap it, and then we're going to stop because we're going to move on to something different. We looked at the skeletal system. We looked at the advanced circulatory system, the numerous properties of the blood, the distinct purposes of arteries and veins, the function of the heart, the digestive system, the immune system, the muscular system, the reproductive system with all of its intricate parts, working from ovulation, fertilization, right through to birth, the respiratory system, the urinary system, including the kidneys and the bladder and the sphincter muscles, the liver, the skin, the eyes, the ears, the nervous system, the brain, and we haven't touched everything that's in the human body. And we've only dealt with this on the surface. All of this and much, much more in the human body. Random chance, no design, no designer, just happened over billions of years through adaptation and mutations? Or is this monumental, unarguable evidence that there is intelligent design in the human body. And if intelligent design, there is an intelligent designer. I don't think we need 3 seconds to make that decision. But that decision is up to you. Again, I emphasize, if someone wants to argue against something, they'll find a reason to argue against it, no matter how illogical it might be. I put the challenge out to you. We're not done yet. We're going to continue to look at some other things. We're going to look at a couple of animals, 2 or 3 animals, because right here we've just emphasized the human body. Then we're going to look at what the scripture has to say, what God has to say about this. And then we're going to kind of sum things up. So I hope you've enjoyed this so far. I hope you stick with us and through the rest of the videos that are going to be in this series. Thank you for watching. May the Lord bless you.